Hello, my name is Eric Zdebski, and I'm your professor for IT217 Programming Languages. Now, what I'm going to do in this introductory session is go over the most important document for this course, for any course really, and that is the syllabus. Now, you'll see that on your screen right now, and you'll find it in Canvas. The syllabus tells you everything about the course, all about the work that you're going to need to do for it, what you're going to need to read, when things are due, what the objectives are of the course, that is, what you're expected to learn. And then it goes into some specific academic policies that are important at the university to make sure you get the most out of your education. So here we go. Go start looking at the syllabus right now. So, like any of the syllabuses you're going to see, they all start off with the degree program, the specific name of the class, when the class is being offered, because these do get updated from time to time. What the schedule is: this class is an online-only class. It's an asynchronous class, so we're never going to meet in person, but we will be able to meet regularly every week, in fact, during my virtual office hours. You'll see my contact information when those office hours are. For this class, we're going to meet Mondays from 7 to 8 U.S. Eastern Time. That's going to be through GoToMeeting, and you can find the link for GoToMeeting in the Canvas, and all of the meetings are already scheduled there. You just click on it for the appropriate week, and it will let you join the meeting. There are no prerequisites for the class. Get 4.5 credit hours. Now we get into what this class is about. So this class is about, well, one of my favorite things, programming. Now, I'm not going to read this entirely to you. You can read it for yourself. But what I will tell you is that programming is a creative process. You're taking some requirements and you're figuring out how to do them the best way possible for your customer. So there's a lot to programming. It's become quite a bit more complicated over time. Certainly since when I started with the basic language 40 years ago. But the tools that you have available now are so much more powerful that teams can become, crazy more productive than they ever used to be in programming. So what are we going to learn here? These I will go over in a little more detail. All right, programming terminology, basic mechanics. That is, how's a program run? How do you build a program? What's the source code? What's the compiled code? The building blocks of structured design of software. So within any program, you've got input, you've got output, you've got control structures, which is a fancy word for if-then statements, or a for loop where the code runs over and over again with some variables changing each time it goes through the loop, so it does slightly different things each time. Algorithm development. This is where you get to use your smarts and figure out the best way, the most efficient way to do some task at hand. Structured design using appropriate notional languages, such as pseudocode and flowcharts. So when you are starting off developing a program, if it's of any significance, you don't just start writing code. You design things ahead of time. Now that design can take many shapes, and there's entire languages, such as the Unified Modeling Language, which can be used to describe software. There are even tools that will take those descriptions and generate source code from them. Not all the code, but enough code that you can start filling in the blanks yourself. Kind of gives you what's called a boilerplate. Now, a pseudocode can represent your software in any language because you just write it in plain English. and you kind of explain the flow of the algorithm, what data it's using, and just the concepts in English of what it has to do. You know, read input from the keyboard, process the input, output the input. What I just did there was explain another fundamental thing about any software program. It consists of 3 steps: input, processing, and output. Every program can be decomposed to that. Now, pseudocode's good for explaining how a program works to a non-programmer. It's good for getting a team started on it because it's easy to read and understand what was expected. And then this other tool they mention here is flowcharting. So again, when you go through your code, you go through the problem, you may have to go through control structures, like if-then statements. Those are decision points. So in a flowchart, you start off with some initial state of a program. You move to the next state because of some change, right? Somebody's typed in some input to the program. Then the code does some function, maybe it's a math function. Maybe it has to check some data. In the big example in this course, it's an ATM machine programming assignment, and it has to check your PIN. So one of the decisions that a flowchart would have in it would be, did you enter in the correct PIN for the user? If you did, proceed to give the user the opportunity to do the ATM functions. If you did not, then go down another path that may say, error message, you put in the wrong PIN, and send you back to the beginning of the program to do the input all over again. All right, number 4, solid grasp of core concepts of object-oriented design. This is a complicated topic. It's an older topic, and the oldest languages don't use it, but all the languages from the 90s on pretty much are able to use it. It might have existed even in the 80s, at least in some small instances, and certainly in theory. So, objects. Everything is an object. What's an object? My phone is an object. It has some properties. It has a name. It has some capabilities, some functions. It has size, weight, height, width. It has connections, inputs, and outputs. All of those things can be used to create a model of a phone in software, an object. Now, an object is a non-physical concept, but a class is the physical thing. So I describe a phone on paper, but then the real phone, this is the class, a specific instance of a phone that my software can work with. Now, objects can share properties with other objects. They can inherit from them. Like you could have a car object, and then within that family of objects, child objects. So you may have car, and then you'll have different types of cars. You may have something even more generic. Maybe you just have automobile, and then within that you have car and truck and semi and fire truck. Those would be children of the parent, the automobile. They inherit properties from it. Now there's some other properties here of object-oriented programming that are complicated terms. Encapsulation and polymorphism. I'm not going to go into those right now because we'll be going into those way later in the class. But I'll tell you that encapsulation is important for security, and polymorphism, we'll get into it later. All right, number 5, apply critical problem-solving skills and programming logic to design and implement solutions to real-world problems. So as I said, the class assignment, the project for the whole term, you'll be building an ATM program, that is. So that problem is going to give you the ability to learn how to analyze and design and develop software using modern tools and techniques. And you'll get some opportunities through the discussions to go into some supplemental learning areas above and beyond programming, but they get into the tools and techniques that professional software engineers use every day. All right, we have a textbook starting out with programming logic and design, the 6th edition. You can rent this textbook. It's about $10 a month. It's a lot cheaper than buying it. The price is expensive to buy, but it's inexpensive to rent an electronic version of it. The book itself is language neutral, so it doesn't teach you how to program in Java or Python. It teaches you general principles that apply to all the major languages. So for this course, C++ actually is the language that we'll be using. And the book comes with a C++ supplement. So you get the theory in the book, and then the supplement goes into the specifics for that language, enabling you to learn how to apply the theory to writing the code in that specific language. You need the book. Get it soon. Okay, there's a lot of resources that WUST provides. We've got a library. We've got all kinds of journal subscriptions. You can read about all kinds of other advanced programming topics, or basic programming topics for that matter. Whatever floats your boat. There's some links there for where to find the textbooks. And then there's some mention of the APA handbook. So we have some guidelines for how we write, and we're following the APA guidelines. So this handbook is important. That's free. You can just download it anywhere. Okay, for how we're going to learn in this class, there will be lectures in the sense that when I'm giving office hours, I'll be lecturing. We'll have guided discussions, so there's going to be discussions every week on topics that I've selected for you to go into that supplement what you need to know as a programmer. There are assignments. There's not group study, but there are assignments. And presentations and demonstrations. Some of you may get to present or demonstrate your software. You'll be doing that obviously in a virtual fashion. Maybe all of you. We'll see. We'll see if I can fit that in. Learning how to give presentations is an important skill for anybody in IT, software, business, doesn't matter what field. Okay, grading. These are pretty standard numbers. Participation is 15%. What's that mean in a virtual class? That means if you did the discussion that week, you participated. That's what it means. Not just the assignment, but the discussion. So you got to do the discussions. Because the discussions were 25%, and then participations were 15%. You add those two together, 40%. Wow, that's a big piece of your grade. So you want to both do the discussion work and participate that way. Weekly assignments, 20%. And then it says midterm exam, case study, 20%. What that is there's a programming assignment. And then there's the final exam with the final project. It says report. It's not exactly a report. But the final project is to finish the programming assignment. So you start early in the course on building up functionality on the ATM. Halfway through the course, the midterm, you turn in what you've done so far, show that you've got some working code and that it's meeting the requirements at the 5-week point. And then you continue working on that through the rest of the term till at the 10-week point you are now complete with the project and you're able to submit all the code and make sure everything's working and it's passing that's passing the requirements. It's doing what it's supposed to do, that me, the customer, has asked for. Now the grading is very standard. You see it right here. A, B, C, D, and F. This is the typical grading scale used, I guess, just about everywhere. Now, the weekly course outline. Again, I'm not going to read all this. There's 10 weeks of stuff here to read, but you need to be aware of it and know it's in the syllabus. So in the first week, list the objectives, and it ties these back to the student learning objectives. So number 1, you go back up in the syllabus and you'll see number 1 right in here. So you can always connect what you're reading and why you're reading it. So it tells you to read chapter 1 in the book, do weekly assignment 1, discussion board 1. Then they're all due at the end of the week. They're due Sunday night. Sunday night at 11 is really a good time to get everything in. Then it won't be late. Late means after midnight. When things are late, by the way, you will get deductions. Week 2. More information about what you're supposed to learn, how it ties back to the course objectives, what to read, and weekly assignment 2 and discussion board. Continue on. There's a midterm project you turn in, there's the discussions, and then there's a midterm exam. There's a final exam, finishing up the final software project, final discussion, which actually the week 10, this one's really easy. You give me feedback about the class. I want to know what you thought about it, how we can make it better, what you liked, what you didn't like. All right, general policies. Again, this is all in the syllabus. I'll give you one single document where you can find everything you need to know. We already talked about attendance for this class. Follow APA writing standards. That's a definite. There are rules to follow. You need to be aware of them. Here's the information on late assignments. You've got 3 weeks to get it in. So after the due date, 1 week, you lose 10 points. That's a whole letter grade. 2 weeks late, you lose 15 points. 3, 20 points. Now you're down 2 grades. The best you can get is, what, a C+, basically. After 3 weeks, unless there's some other circumstances, meaning you got to talk to me to get this cleared, you don't get any points. So you got to get your work in. You can't wait till the end of the course and think, oh, I can just turn my work in then. You're not gonna, because you're gonna get zeros. All right, so here's some basic information on using the APA writing standards. Cover page. Don't have one. If it's not formatted right, you lose points. Not insignificant either. How to name the document. That's a tough one. Name it right. Put your name on it. Name it right. Put your name on it. References. This is an academic course. You're in college. You got to provide references and show where you use the references in your paper. You can't just give me a list at the end that I'm supposed to somehow magically figure out what you used and where you used it. You have to connect the dots. So if you got reference 1 and reference 2 and 3, and you should have at least 3 references, then you show in the paper where you used reference 1. The APA tells you how to do that. Gives you guidelines for how to both create the references and then to cite them. Citations in your paper. Discussion forums, there's some instructions here on how much you need to write. You don't just, write trivial comments. My discussions, because of student feedback, my discussions are based on topics that should enhance the course, that will require you to go out and do a little extra reading outside of the book, get out in the internet a bit, do some reading there, and learn some more topics about software engineering and programming. There's no extra credit. Okay, you want to do your discussions early, get them done early in the week. Otherwise, there's not much discussions. We want this, each of you to interact with the others. Ask questions, reply to other comments. I should state that specifically here. So you don't just post your discussion and walk away. It says here, make a post with references and comment on at least 2 classmates' posts. So you need to be reading each other's posts, learning from each other, asking them questions, and learning more, right? All right, and the final piece, academic misconduct policy. This is focused on 2 things: use of AI, which is prohibited for generating your content. It doesn't mean there aren't cases where AI could be used. You just can't use it to write your paper. Right, and plagiarism. Plagiarism, copying others' work without giving credit. Okay, that without credit is important. You can't use somebody else's, use some reference and then not put the reference in your paper. That's actually plagiarism. Now, what happens with plagiarism? Well, here we go. First violation. Now, the Turnitin scores will tell you if your plagiarism similarity index is too high. So when you submit a paper to Turnitin, it will analyze it and give you a plagiarism score. If it's over 30%, you've got to revise that because it's going to get hit as plagiarism, and you will get a 0, just like it says on screen. Then you got to turn the paper back in after you fix your problem, right? After you've removed the material that was plagiarized. Or in the case of AI, if you get too high an AI score, and there are other telltale signs of AI use, not just the score, by the way. So too much AI, get a 0. Got to resubmit the paper. The second time, if you're caught a second time with a paper with plagiarized content or too much AI content, the best grade you can get is a C for that paper. That's it. Doesn't matter how hard you work. And you've got to obviously resubmit the paper. The third violation, whether an AI or plagiarism violation, results in failing the class. This does happen. Trust me, I've failed students just last term for use of AI. All right. Now here's a good tip. Do not rewrite the question in your answer document. The plagiarism checker score will be high if you rewrite the question, because it's gonna find that, it's gonna find that text somewhere and go, oh, you plagiarized it, even though it's just the question. But still, you don't want to do anything that jacks up your plagiarism score, that's for sure. Okay, netiquette. Be professional in your interactions with other students. Be professional in the discussions. And that's going to be most of your interactions with students, at least for this class. Other classes you'll be in person sometimes, whatnot. So that professionalism is not just in the discussions, it's overall communication, right? We want to teach people to communicate in a proper business-like manner. So the discussion boards, think of it as, you need to properly communicate with people and be respectful. Writing emails, be respectful. Make a professional email. Don't just send off what first comes to your head. You may want to rewrite things, check spelling, check grammar, so that, like it says here, maintain a polished and respectable image in your correspondence. Then there's some resources here. All right. So that's it. That's the course. This is a self-driven course. You're given the assignments. You'll find them in Canvas. The discussion topics are in Canvas. And you got to go to work from the beginning. Start reading. Start doing the work. talk to me, ask me questions, send me emails, come to the office hour sessions if you got questions there. I will be, if people are there, obviously I will be answering their questions. If people are not there, then I will be talking about some topic related to programming. I do programming as a hobby. I program in multiple languages, so you can ask me all kinds of questions. I program embedded devices. I program vintage computers. I program modern computers. I've programmed in the past smartphones, pretty much everything. So I'm your resource to help you become better programmers through this course. All right, that is all I've got. Check the syllabus. Be aware of its content. Number one most important document in the class. Oh, you know what? Where will you find the syllabus? Let's see. You go into the course. We'll look at it as the student view. This is what you'll see. The syllabus, right at near the top here in the initial welcome. And then a bunch of information, and then week by week, assignments, discussions, and so on and so on. Supplemental material on topics relevant to the course. Actually, these are, materials from the book, actually. It's like a teaching resource. I wish you well during the course. It's going to be fun. Programming is fun. It's a creative activity. It's a fun outlet. And yeah, good luck. Enjoy the class.